Hi guys, welcome to Algebra 2 Honors, Chapter 1, Section 1. This is our first video. We're going to try this out and see how it goes. So just so I know that you're doing what you're supposed to, go ahead and look at me and make a silly face. No, really. I mean, like right now. Make a silly face? Good? Alright. So we're going to start really easy in the year, doing patterns and expressions. I'm going to go ahead and go through the vocabulary. Well, first our objectives are to identify and describe patterns. So I'm just going to go through the vocabulary. You can pause it after each definition if you want to and write it down, or you can just wait until the end and pause it. So, constants. These are quantities whose value do not change. So can you think of something that's a constant? A value that doesn't change would be a number, like 1 or 3. Their values don't change. Variable quantities are quantities that vary or change. Usually, we show variable quantities using a variable, which is a symbol, usually a letter. Give me the most common one. Of course, it's x or n. Those are the most two common variables. Next, we have a numerical expression. This is a mathematical phrase that contains numbers and operation symbols. Try and think of an example of a numerical expression. Three plus 5 or 8 minus 2 plus 5 are numerical expressions because they use numbers and operating symbols. We don't use variables in numeral expressions. But in algebraic expressions, we use numbers and variables in math operations to make algebraic expressions. So like 3n plus 5, 8x minus 2 plus 5n. These are all algebraic expressions. So, go ahead and pause the video if you need to. Write down the vocab. First thing we're going to do is identifying a pattern. So let's look at these figures and see if you can tell me what the next figure would be in the pattern. Do you see a pattern? Hopefully you do. The triangle has how many sides? 3. A square has 4. Pentagon has 5. Hexagon has 6. So next we would make what's called a heptagon, which has 7 sides. Good luck trying to draw that. What about this one? Do you notice a pattern with this one? I hope so. This one's pretty easy. We have a red center and 1 square each side, 2 squares each side, 3 squares each side. So the next figure in the pattern would be 4 squares on each side. Woohoo! You're smart. Okay, so using algebra, this makes it a little more difficult, but we're still going to look at patterns. So let's say we have 4 toothpicks that makes up a square in our first figure. Our second figure, we have 2 squares, and our third figure has 3 squares. How many toothpicks are in each figure? Well, our first figure, so our first figure uses 4 toothpicks, our second figure uses 8 toothpicks, and our third figure uses 12 toothpicks. Do you see any correlation between the figure number and how many toothpicks there are? Each one of them is times 4. So we could continue making the pattern, or if I just asked you, what's the 20th figure in the pattern? What could you tell me? Well, the 20th figure, you would just do 20 times 4, and everyone knows 20 times 4 is 80. Awesome. Okay, here's a chart that they use in the book that can help you. Sometimes they won't be as easy as this. So you have your input, that's what figure number you're on. Your process column means what did you do to get to your last one. So what if we just said the n figure? What do we have to do for each one? We take n, multiply it by 4, so 4n would give us the value for any figure in this pattern. Alright, so here's another one. So it asks how many tiles are on the 25th figure of this pattern. Show a table of values with a process column. I want you to go ahead and pause here after you make a process column. So you're going to have your input, your process, and then your output. So go ahead and pause. See if you can figure out the pattern here. This one's a little bit trickier because it doesn't start right with 1. If we had a first pattern, it would look like this. So they didn't actually give us the first figure in the pattern. So the first figure would be 1 times 2, give us 2 squares. The second figure is 2 times 2 to give us 4. The third one is 3 times 2, which gives us 6. And the fourth one is 4 times 2, which gives us 8. So again, what would be our expression, our mathematical expression, to give us any figure in the pattern? It would be 2n. So if I asked for the 25th figure, like it does up here, what would you do? 25 times 2, which is 50. Good. Alright, so using a graph and a story problem, I know you're super excited. So you want to set up an aquarium. You need to determine the size tank to buy. So the graph shows you a rule that relates the capacity of the tank, so that's how much water is in the tank, combined with the lengths of the fish. So you added the lengths of the fish. So you want 5 2-inch platies, 4 1-inch guppies, and a 3-inch loach. What's the smallest capacity tank that you could buy? A 15-gallon, a 20-gallon, or a 25-gallon. So what is it that we need to do first? We need to find out how long each of our fish are added together. So if you have 5 2-inch platies, that's 10 inches, 4 1-inch guppies, that's 4 inches, and a 3-inch loach, it's 3 inches. So if you add them together, that makes 17 inches for a total of all your fish. Now let's go ahead and look at this graph. If we have this point here, that's 0, 2, and if we have another point here, that's 2, 4, and if we have another point, that's 4, 6. Are you noticing a pattern? I hope so. So whatever your input is, your process is to add 2 to get your output. So if our fish total 17 inches, if we add 2 to that, we need to have at least 19 gallons of water. So what's the smallest tank that we could have? A 20-gallon tank should be your answer. Alright, I want you to go ahead and answer these questions and then get with your partner and go over them together after you have both finished. And then your homework is to do lesson 1 on Math Excel, and let me know if you have questions. Have a great day.